Hello folks, in this video I'm going to show you how to perform a hypothesis test around two population proportions. This is a little different than around the two population means, and I'll show you how it is different. We don't have a nifty function in Excel to do this straight, so we will be creating a template here. But before I get into that, there are a couple of values I want to cover. So when we're doing the proportion problem, we need to be able to calculate this p hat, and this p hat is going to get us to our test statistic. Now, as previously, anytime we were dealing with proportions, we're going to be using the standard normal distribution around 0 and 1. Okay, you're not going to be using the t-distribution in the case with the proportions. And remember, for our hypothesis test for proportions, P1 equals P2. This is our null hypothesis. In the boring case, we want to disprove this. Then we have the possibility of a left tail test, a right tail test, and a two tail test. Okay. So we'll keep all of these values in mind, but this is the problem that we're going to be doing today. So it's a pretty long problem because there's a lot of things we need to take out, but mainly we need X and we need N and we need X for the first data set and X and N for the second data set. So I'm going to pull out the valuable things. Total of 5,310 patients received bare metal stents. And of these, 832 need treatment for reblocking within a year. So this is my X for the received bare metal stents, and this is my N for received bare metal stents. Total of 1121 received drug-coated stents. 128 required the treatment. Can you conclude that the proportions of patients who needed retreatment is less for those who received drug-coated stents? So what we're saying here is P1 is bare metal, and this is why it's so important for the bookkeeping with these. They're saying P1 is greater than, P2. All right, so let's go ahead and start putting some of these things into our brand new shiny template. What are we gonna need? I need, really from the problem, all I need is X and N and whatever alpha I'm gonna compare it against. Everything else is gonna be calculated inside of it, which is kind of nice. So let's see if we can get all the right stuff in here for our problem. Let's see. I need X sub 1. I need N sub 1. I need X sub 2. I need N sub 2. I'm going to start right there, and then I'm going to create my p hats from there. I'm also, so I keep everything straight, 1 equals bare metal, and 2 equals drug coating. You could also write experimental, X drug coded. It's fine, whatever is best for your template. You choose how to create it. 832 is the number that did need that retreatment. 5310 is the number that didn't need it. 128 for the drug coded, 1121. The only other thing I need from this bad boy is the fact that I want P1, include that drug-coated stents less than. So P2 should be less than P1. Let's put that over here. P2 should be less than P1. I could do this as a left tail test if I want to by putting P2 less than P1, but usually what we see is P1 greater than P2 is a right tail test. Okay, so let's finish this up. What do I need? I need P hat 1, P hat 2, which, since I was very careful to designate what is going to be X1 divided by N1, and this is the same thing, equals X2 divided by N2. Okay. So we already see that this proportion is less than this proportion, so that is a very good sign. What else do we need? I call this big P hat, so it takes it away from P hat 1 and P hat 2. So I'm going to call this big P hat. I know it is just P hat right there. but I'm going to calculate big P hat as x1 plus x2 divided by n1 plus n2. I'm going to pull up the formulas view so you can follow along with your formulas, or pause the video at any time so you can put the formulas. It's going to keep it a secret until the very end. Very exciting. Okay. This is kind of a monster, so I'm going to break it up into 3 different pieces. This is going to be my numerator, my denominator part 1, and my denominator part 2. So this is numerator. This is z numerator, z denom 1, z denom 2, and then finally my test statistic is going to be this divided by this. Okay, square root of that, but you get the point. It's most of the way there. Okay, so this is equal to P1 minus P2. This is another reason to keep P1 on the left and P2 on the right, so you don't have to change your formula over here. Okay, my first part of my denominator is P hat, big P hat, times, do not mix up your P hats, minus big P hat again, and that's the entire thing. This one is 1 divided by n1 plus 1 divided by n2. Now our test statistic is this numerator divided by the square root of these 2 bad boys multiplied by together. Okay, this times this. Now I have everything at my disposal I need to calculate my p-value. And which p-value am I going to do? This is a right-tailed. Remember, if I'm doing right-tailed, Excel is not very smart. We have to be smarter than Excel. It takes the area from negative infinity on the left all the way to your test statistic. So if your test statistic is positive, which is going to be, and I'm doing a right-tailed, I have to do 1 minus norm.dist. And my test statistic, 0, 1, always true with cumulative. What does my p-value say? Blam! My p-value is very, very, very small. This makes sense. We already saw that p hat 2 was smaller than p hat 1. We just didn't realize it was proportionally that small. Holy moly's. We are definitely going to reject the null hypothesis. And I think there is plenty of evidence to say that those patients that received the bare metal stents had to get a lot more of the retreatment. I'm going to bring up the formulas again so you can pause it there and write down anything you need, but go ahead and make yourself a template. It'll help you out a lot.